Have you ever looked at the sky and thought we knew the secrets of our own cosmic backyard? Think again. In the frozen confines of the solar system, a world that for decades was considered just an inert ball of ice and rock has just revealed itself as one of the most exotic and surprising places we've ever observed. I'm talking about Pluto. And what if I told you that a crazy idea, ridiculed by many in the scientific community, was recently confirmed by the most powerful space observatory ever built, forever changing what we know about planetary atmospheres? Get ready, because the story I'm going to tell you today doesn't just involve cutting-edge science, but also proof that the strangest ideas can be the most correct. Let's uncover how the James Webb Telescope confirmed that on Pluto, it's not gases, but a mysterious living haze that controls the entire climate of the dwarf planet, in a cosmic ballet never before seen anywhere else in the universe. The truth about Pluto is much more fascinating than fiction. To understand the magnitude of this discovery, we need to go back a bit in time. Until 2015, the image we had of Pluto was, to be honest, quite boring. A distant point of light, a world demoted to dwarf planet status, which we imagined to be simply a frozen and geologically dead body. But everything changed when NASA's New Horizons probe made its historic flyby. The images it sent back to Earth left scientists with their jaws dropped. Pluto wasn't a boring ball of ice. On the contrary, it was an incredibly active world, with water ice mountains the size of mountain ranges, plains of frozen nitrogen, and, most intriguingly of all, a complex atmosphere filled with layers of haze. This revelation was a shock. Pluto had a personality, its own dynamics that no one expected. From that moment on, it stopped being a mere supporting character in our books and became one of the main study targets of the solar system, a puzzle we needed to solve. The haze was the most mysterious piece. Where did it come from, and what was its role? The answer to this mystery began to take shape in 2017, not in a large laboratory, but in the mind of an astronomer named Shi Zhang from the University of California. He proposed something that, at the time, sounded absurd to many of his colleagues. On all planets with atmospheres that we know, including our own Earth, temperature is regulated mainly by the gases present. It's the greenhouse effect, a concept we learned in school. Gases trap heat from the sun and keep the planet warm. Zhang, however, looked at Pluto's data and suggested the unthinkable. What if on Pluto it was different? What if the key to the thermal balance of the dwarf planet wasn't in its gases, but in the solid particles that formed that enigmatic haze? He theorized that these particles, composed of frozen hydrocarbons, could be absorbing solar light and radiating heat back to space, actively cooling the atmosphere. It was a crazy idea, a complete inversion of what we understood about planetary physics. Many doubted, but Shi Zhang made a bold bet. He predicted that, if his hypothesis was correct, Pluto should emit an intense infrared glow, a specific heat signature that could only be detected by the most sensitive instrument humanity was about to launch, the James Webb Space Telescope. The prophecy was made, the idea launched. Only the final test was missing, and it came. Inspired by Zhang's audacious theory, a team of astronomers led by Tanguy Bertrand from the Paris Observatory decided to use the incomparable power of James Webb to settle the debate once and for all. Between 2022 and 2023, they pointed the telescope's golden gaze at the small point of light that is Pluto. Using the MIRI instrument, designed to see the universe in the mid-infrared spectrum, they measured the energy emanating from Pluto's fragile atmosphere. The tension was palpable. Would Zhang's idea be confirmed, or would it go to the trash can of eccentric scientific theories? The result, recently published in the prestigious journal Nature Astronomy, was spectacular. Shi Zhang's prediction was absolutely correct. James Webb detected exactly the infrared radiation signature he had predicted years before. The confirmation was a moment of euphoria for the team. In just 6 years, a radical hypothesis went from crazy idea to proven scientific fact. It was a victory of boldness and intuition, accelerated by revolutionary technology. Planetary science had just taken a giant leap. But what does this mean in practice? It means that Pluto's atmosphere works in a unique way throughout the solar system. Just imagine, this mist, composed of frozen particles of nitrogen, methane, and carbon monoxide, isn't static. It moves in a constant cycle. The particles rise, are heated by the weak sunlight that reaches there, and then descend, cooling and releasing this energy to space. It's as if the haze itself breathes, regulating the temperature of the entire planet. While on Titan, Saturn's moon, there's also a haze formed by chemical reactions. Its role isn't as fundamental as on Pluto. On the dwarf planet, this haze is the queen of climate, the central piece that maintains the delicate balance between the little energy that arrives from the sun and what Pluto loses to the cold vacuum of space. It's an atmospheric mechanism we had never imagined possible, and that we now have proof exists. And as if all this wasn't strange enough, James Webb's observations revealed another bizarre phenomenon: a cosmic dance between Pluto and its largest moon, Charon. While Pluto is dynamic, Charon is almost an atmospheric desert, a world practically without air. However, the data showed something fascinating. The ice on Pluto's surface isn't fixed. With Pluto's long and slow seasons, vast amounts of ice, mainly nitrogen, move from one region of the planet to another. And the most incredible part is that some of this ice seems to be transferred directly from Pluto to Charon. Think about that for a second. A dwarf planet is literally snowing on its own moon. This type of volatile material migration between two distinct celestial bodies is another behavior that has no parallel anywhere else in our solar system. It's an intimate and active connection between two worlds, separated by thousands of miles of space. This discovery goes far beyond satisfying our curiosity about a distant world. Understanding how Pluto's exotic atmosphere works can actually give us valuable clues about our own past. Scientist Shi Zhang, the author of the original crazy idea, explains that primitive Earth, billions of years ago, also had an atmosphere rich in nitrogen and hydrocarbons, very similar to Pluto's today. Studying this natural laboratory at the confines of the solar system can help us model and understand the conditions that allowed life to emerge here. Pluto, the former demoted planet, has transformed into a time machine, a window to a distant past of our own home. It reminds us, in a humble and spectacular way, that the universe is full of surprises and that there's always something new and revolutionary to be discovered. You just need to have the courage to propose a crazy idea and the right tool to prove it. And so, small and icy Pluto gave us a monumental lesson about creativity, perseverance, and the infinitely surprising nature of the cosmos. A lesson that was only possible thanks to human genius and the penetrating vision of the James Webb Telescope. Did you enjoy unraveling this cosmic mystery with me? If this journey to the confines of the solar system blew your mind, then don't forget to leave your like here on the video, because that really helps our work reach more people passionate about science. And of course, if you're not yet part of our community, click the subscribe button and activate the bell to not miss any of our future explorations. Thank you very much for your company, and see you next time.